Hello, my name is Steven. Welcome to HiFinder Tech Talks, where we understand the technology that makes the hydrogen economy work. Today, I am very pleased to welcome Jan Andreas of Anleg. He has spent the last 20 years building up a company around hydrogen storage and systems, essentially. This is a great pleasure to have you here, Jan. Welcome to the HiFinder Tech Talks.
Hi, Steven. How are you?
I'm very well, thank you. And I see you are literally walking around with a tank system. I know you know a lot about tank systems.
Yeah.
And please, before we just delve into that, what is this that you had with you?
That's the basic component of a tank system. It's a so-called on-tank valve, OTV, which is mounted on the tank in order to be able to disconnect the hydrogen supply and open and close the hydrogen circuit. And with some safety features, the tank is refueled via this component, and in case of fire, it's emptied via this component.
Okay, so this basically sits on top of a tank, essentially, yes. Yeah? And you can fill the tank, empty the tank, and there's even a wire.
Yeah, that's for the solenoid valve. So there's a two-way solenoid valve which is opening and closing the tank.
Yeah.
There is a pressure sensor integrated. And we have normally also a temperature sensor, which is inside here, this component, so that you can monitor the inlet temperature, inside temperature of the tank.
Okay, perfect. Well, okay, this is great, and I know this is an essential part of a tank system, but tell us, what exactly is a tank system, actually? I mean,
yeah, a tank system, of course, starts with a tank, and then you have on one end, you have the OTV. If the tank is longer than 1.50 meters, you have also a thermal pressure relief device, which is called TPRD, which you mount on the opposite side, so that independent where the fire is located, the tank is emptied before the structural structure of the tank is destroyed by the fire. Sorry, yeah, exactly. What's funny is especially on fire safety is that the tank which is coming out of the fire is cold. Is really cold because it's emptied so quickly that it's cooling down. So there is absolutely no risk if the valves are designed correctly that the tank is destroyed or exploding or whatever else.
So the good thing is, I see you brought a real photo of a tank system with you.
That's a photo of a hydrogen tank system for a 40-ton truck. It's approximately 40 kilogram of hydrogen available. So you see, we integrate the tank system into existing truck, and so we have to use, of course, what is available.
Yeah.
We are not designing a complete new truck. We integrate and implement the tank system where we get places for. So you see here, this is the side where the on-tank valves, the OTVs are mounted, and on this side is
the OTVs.
No, sorry, the thermal pressure relief devices.
So
this one
here on this side here, the thermal pressure release, and on the other side you have
the on-tank valves.
The on-tank valves. Yeah. Okay, all right.
That's the tank system. Of course, you have to reduce inside the tank system to a lower pressure because the tank system, this is a 700 bar system. You have also 350 bar system for buses or last mile logistic vehicles.
Yes.
And then you have, this component here, it's a gas handling unit we have developed. Instead of having single components, we have everything in one valve block, and there you have all the sensors which are running the hydrogen. That means high pressure sensor, temperature sensor, another solenoid valve, a pressure regulator which is regulating down to the fuel cell pressure, and a controller.
Okay, so we have here another picture of essentially a system like that. So if I understood you correctly, the tank system comprises not only the actual tanks, but all these valves that go with it, and the gas handling unit, essentially with all the sensors and everything. So, so the output of a tank system is essentially hydrogen at the right pressure.
It's the hydrogen at the right pressure. It's also comprising the refueling nozzle, where you connect to the refueling station.
Yes.
You have some which have an infrared interface, so that the refueling station can get in contact with the tank system and knows what it is and what it has to refill. So that's one part. And then you have, of course, the different tanks depending on the quantity of hydrogen which is needed. And afterwards, you have the gas handling unit and the valves reducing to the pressure of the fuel cell.
Okay, all right. And this was the filling was from there. Okay,
That's the filling.
that's
also.
the filling there. Okay, okay. So yes, we can just move this on to yes. No, I have a bit of a thing today. Yeah, there we go. So I know you explained you explained this to me a little bit earlier, but maybe you can just take us through this one more time and say, so I know from a technical perspective there are some boundaries. So where would you draw the boundary of the tank system?
Yeah, the boundaries we have four boundaries. One boundary is the refueling. It's this with the refueling receptacle. You have pressure sensor, temperature sensor, infrared interface, which is then guiding the hydrogen towards the tanks. That's the first one. The next one is the tank itself with the OTV and the TPRD.
Yes.
Which is minimum 1 up to whatever is needed. The third one is the gas handling unit or the regulation where the pressure regulator sits, which reduces the pressure towards the fuel cell pressure. And the fourth one is now it's here. It's the interface towards the fuel cell or the application which is using the hydrogen. We see more and more vehicles with fuel cells and more vehicles with hydrogen combustion engines. So both are using the same tank system.
Both are using the same tank systems. Okay.
Exactly.
So yeah, just a thing that I learned here. So what we actually see here is a PNID of a tank system with well, let me say n number of tanks. So we have one, and this could be any additional number. When we speak of additional numbers, I mean, before we saw a photo of a 40-ton truck. So how much hydrogen can you put into a vehicle? How many tanks can you have?
It's mainly depending on the size of the vehicle. So normal passenger cars, we are talking about 4 to 6 kilogram of hydrogen. For mid-sized buses or mid-sized trucks, we are talking about 20 to 30 kilogram. 40-ton truck is something like 40 to 60, or they would like to have 70 kilogram implemented, but you don't have the space, so that's another topic.
That is a challenge, yeah.
And we have application like on ships where we integrate 4 tons of hydrogen. But here's a nice picture how you can implement or where you can place the hydrogen system or the hydrogen powertrain if you want. So you have mainly on the truck, you have behind the cabin, standing up, you have the hydrogen tanks. You try to put the batteries, because these are heavy, to equilibrate the weight of the vehicle, because you take a heavy engine out of the vehicle and you put a very lightweight fuel cell inside the vehicle. So you need weight up front. That's why you normally try to place the batteries up front. Then you have some heat exchangers, you have the fuel cells, you have the DC-DC converters, and then you have the electrical powertrain inside the vehicle. So that's typical integration of fuel cell system into a vehicle.
Okay, I've often seen them, put the tanks behind there. Have you seen other configurations? I mean, I've thought sometimes maybe on the roof, but there you have normally the sleeper cabin. So have you seen other configurations? Yeah,
there are now new configurations where they place the tanks between the wheels. The problem in Europe is the regulation of the length, which is limited of the vehicle. And on the 40-ton trucks, we have a problem to place it between the wheels. In the US, it's much easier because they are allowed to use longer trucks. And then you can place it easily in between. And that's why we put it behind the cabin.
So that means if you had a wish of however long you could make the vehicle, where would you place them?
I would place them along between in the center of the truck, in the middle.
In the middle of the okay. And why they're safe, or just
on this side you're most far away from any impact. If you have a side crash, you don't have any you don't have an impact. If you have a rollover,
Yeah.
you are quite close from the center. You're quite close to the center of gravity, so
Yes.
the acceleration,
Yeah.
falling the truck to the side is quite less impact.
Okay. Yeah. Wow. Interesting. But I initially said, so how much can you put on a vehicle? That depends on the vehicle. So 40 kilo for 40-ton truck. I remember that. But
Yeah.
I know, and I think we have here also some photos of other even bigger systems that you've made. If I get it right here.
That's a bus tank system.
Yes. Mm-hmm.
That's approximately 28 kilogram, because buses don't need so long distances because they are running a certain time.
Yeah.
And normally they run between 200 and 350 kilometers. So the weight of 30 kilogram of hydrogen is sufficient. Mm-hmm. Absolutely. So it's also depending on the running mode of the vehicle, how much hydrogen you need. You have some last mile logistic trucks which only do 200, 300 kilometer.
Yeah.
They would not need any 40 kilogram of hydrogen. They can run with 20, 30 kilogram also.
Okay. I know you've worked on even bigger systems. There we go. On marine applications where I think they even need much more.
Yeah, that's an interesting, that's Electra pushboat. It's the first pushboat without a diesel engine at all. It's only running on fuel cell and on batteries. And here we have placed 700 kilogram of hydrogen on board in special designed cartridges to fit into this ship with 3 fuel cells. So the ship can run either on batteries or on fuel cell. There is no diesel engine at all inside. And here the difference is not to being obliged to refuel the ship in the harbor.
Yeah.
We can take, you see there's a small crane.
Yes.
So the ship can unload to the Kaimauer.
Yeah.
Sorry, I don't know the English word.
Yeah.
To the Kaimauer, and then you just swap the containers, and you don't have a bunkering process of hydrogen on board. And that's from the regulation side. Bunkering of hydrogen is not defined at the moment.
Yeah.
So we swap the containers. That's a quite known application in maritime applications. And
swap
we have,
containers.
We have 700 kilogram on this ship, and we are planning other ships where we have 2 tons, 4 tons, up to 10 tons with 1.2 megawatt of fuel cell power.
10 tons of hydrogen
Yes.
onto a ship.
Yeah.
Wow.
And they can run approximately 100 hours fully decarbonized.
Wow.
That's a really exciting
Okay, that
project.
is totally exciting. And you mentioned this is a push boat. So the push boats are the ones that in the harbor that push the big ones around. Yeah. Okay.
Yeah.
They have the really big engines, aren't they?
Yeah.
Ah, okay. Yeah.
They have up to 2 megawatt engine power.
Yeah. They have the massive energy demand. Here we can see those.
Yeah, here you
pods,
can see the crating of the tank system, and.
Okay, Jan, I need to use the opportunity. So we've talked about putting pods in, but I mean, let me say the classic case of where you have a tank and you want to refill it. Yeah, let's talk a little bit about the refueling, because I know for the vehicles that is clearly an advantage because it can be done quickly. However, I hear different things: temperature, challenge, and then again, there's people saying, yeah, not all regulated. Even for the ships you mentioned, there's something. So first of all, let's talk about refueling. What's going on there?
Refueling. There is a official ISO standard for refueling procedures. It's the ISO 2601,
Yes.
which is defining the refueling process for quantities up to 10 kilogram of hydrogen. There is a new version written for larger volumes between 10 and 50 kilograms. It's implemented, so today we can refuel trucks, but we refuel them slowly because the right procedures are not fully validated now. But we can refuel it, that's for sure, and we can refuel them safe. And a vehicle, a passenger car, is refueled within 3 minutes.
Okay.
A bus can be refueled approximately with refueling of 30 kilogram approximately in 10 minutes, which corresponds to the refueling of diesel.
Yes,
So you don't have a time issue corresponding to a diesel vehicle. It's the same time of refueling. If you refuel your passenger car, you also need 3 minutes.
Yes. Okay.
So that's uncritical.
So that means for up to 10 kilograms, it's well regulated and it's in the works to get the ones for the bigger ones going. Yeah.
Exactly. What is a bit an issue on refueling is that during the refueling process, I think we have a slide on this,
Yes.
is that you get a hot spot. The hydrogen is a medium which gets hot when you compress it.
So this is the cross section of a tank.
Yes,
right?
exactly.
Yeah, okay.
And here we are refueling.
You're putting. Okay.
We put hydrogen in, you see
yeah.
it here.
Yeah.
It's getting cold first, and then it's heating up.
Yeah.
And you have a hot spot inside the tank here in this area.
At the back.
And that's why you have to you try not to overheat the tanks. You cool down the hydrogen on the refueling station side. For 700 bar applications, you cool down to minus 40 degrees, so that you don't overheat during the refueling process.
So you're cooling it so that when it goes in, I mean, as it's streaming out of the nozzle, doesn't that reduce the temperature even more, or is that not a nozzle?
Here it's reducing. You can see a very green spot.
Yes.
But then, as it is recompressing inside the tank, it's getting hot again. It's getting warm
so
again.
We're coming from minus 40 to a little bit colder, then to much warmer again.
Yes.
Okay.
Yes. Of course, we have to keep the hydrogen temperature during the refueling process in the temperature range of the bottle, which means that we are not allowed to exceed 65 degrees in the main cases, because the most of the tanks are designed for plus 65 degree temperature.
Maximum. Okay. And if we didn't cool down the hydrogen before, what would that mean? That means we can now only put it in slower, or what is it?
Exactly. If we don't want to cool, or if we have time, for example, then you can also refuel at ambient temperature, but the process of refueling would take much longer.
So instead of 3 minutes, we're talking 15 minutes or half an hour.
Depending on what is the outside temperature, what is the temperature of your high pressure storage you are refueling from, or are you refueling via the compressors? So that's depending on many parameters.
Okay, I know you build tank systems, and I know these have controllers and so on. And I mean, these days nothing happens without data. I mean, we see even here some cables. I understand that between the actual, let's say, filling station, the fueling nozzle, and the tank system, there is also some data interchange. Can you tell us a little bit about that?
Yes,
please?
of course. What's happening at the refueling station, they have some vehicle which has a communication interface. It's an infrared communication interface, which when you connect the refueling station to the vehicle, tells the refueling station, I'm the vehicle XYZ, I have a tank system, 700 bar, I have 20 bars left or 40 bar left or whatever else. So the refueling station knows what vehicle is going to be refueled and can adapt the refueling process corresponding to the vehicle.
So if it's if the vehicle says, let me say, I'm a truck, I'm a lot, what would it do differently than when a small vehicle comes along?
It's the flow rate. It's mainly the flow rate then, and the pressure increase. You know, they are refueling in ramps.
Yes.
Yeah. So you follow up a ramp, and of course, if the tank system is much larger, the ramp the increase of pressure in the ramp will be much lower.
Okay.
And so you need more time, or you have to make the ramp more upwards to refuel quicker.
Okay. Jan, so I know we're running out of time, but I need to ask you one more thing. I mean, we've seen quite a number of tank systems here. We've seen pods, we've seen that. Now, I know that there's also people talking about liquid hydrogen. So can you tell us, those systems that we've seen, can you also just put liquid hydrogen into them? Or what do you need to do different to make it work for liquid hydrogen?
Yeah. No, they are not usable for liquid hydrogen. Yeah. Liquid hydrogen is getting liquid at minus 253 degrees. And the tank system we have seen here, which are ambient pressure tank systems, they have a temperature range minus 40 and plus 65 degrees. So they are not suitable. Liquid hydrogen, you have to liquefy really the hydrogen. You need a lot of energy to get it liquefied to minus 253 degrees. And the disadvantage is, of course, you have to isolate the tank in a very, very strong way. And of course, if you don't use the hydrogen, you have the so-called boiled out effect, which means that the liquid hydrogen is getting gases, because there is no ideal 100% isolation existing. So you have a heat transfer via the boss, via some screws which are fixing the inner tank, and then you get a warm up inside the tank, and this boil out, this gas you have to put away, because if not the pressure would increase. So these are the cryo-compressed tank systems. So you combine cryogenic and compressed, which makes it more difficult, because you are not only suffering the minus 250 degree, but you are also suffering the high pressure and the delta P, of course. So it's making much more complicated, and the energy is much more higher than if you have a compressed hydrogen tank system.
Okay, that sounds awfully more complicated than that. But I'm sure something that you can also work on if you want to, knowing you with your electrical engineering background and all what you've done. Thank you so much, Jan, for sharing your time with us and for telling us all about this. This has been really interesting. I hope you enjoyed watching this video as well. If you did, drop us a line, subscribe to the channel. Also, I need to tell you that on highfinder.com you can get in contact with people like Jan, where you can see these beautiful components and many other things which are needed for the hydrogen economy. Check it out, it's there to help. Thank you again for watching. Thank you, Jan, for taking the time, and we hope that you watch another video. Have a lovely day. Thank you.
And thank you to the Highfinder team for the invitation.
Thank you.
Thank you very much.
Thank you.